chosen because above 0 degrees Celsius, ice melts. So our heat added for ice can only be applied for negative 29 degrees Celsius to 0 degrees Celsius, and our heat added for water can only be applied for 0 degrees Celsius to 27 degrees Celsius. In the previous sections, we got into the nitty-gritty of the relationship between heat and temperature by learning about specific and latent heat formulas. However, while focusing exclusively on formulas, it's easy to be left without an intuitive understanding of what exactly is going on. We can help forge a more intuitive understanding by looking at something called a heating curve. A heating curve shows the relationship between temperature and heat added. You can see in the diagram on your screen that the temperature of a substance goes up as more heat is added to it. You'll also notice that there are large portions of the graph that are horizontal lines. Here, heat is being added, but temperature isn't increasing. This happens because all the heat at this point is going into changing the phase of the substance instead of making it hotter. So the first horizontal segment represents the melting point where the substance changes from solid to liquid, and the second horizontal segment represents the boiling point where the substance changes from liquid to gas. Heat and temperature, while at first appearing similar, are actually two different concepts. Heat is energy that is transferred from a hot substance to a cold one, and temperature is a measure of the average kinetic energy of the molecules in a system. The two can be related together through the specific and latent heat equations. The specific heat equation is used for finding out how much heat is added, Q, to a substance during a change in temperature, delta T. Q equals mc delta T. Here, m is the substance's mass and c is its specific heat, which tells us how much heat it takes to raise a substance's temperature by 1 degree Celsius. The latent heat equation is used for finding out how much heat is added to change a substance's phase. Q equals ml. Latent heat, or L, is the heat required to change a substance's phase per unit of mass. Latent heat can either be latent heat of fusion for changing between a solid and a liquid, or latent heat of vaporization for changing between a liquid and a gas. Finally, how heat and temperature interact in a substance can also be viewed graphically in something called a heating curve, which shows the relationship between temperature and heat added. It also shows the melting point, which is where a substance turns from a solid to a liquid, and the boiling point, which is where a substance turns from a liquid into a gas. As heat is added, temperature goes up, except during the horizontal parts of the curve, where all the heat is going into changing the substance's phase instead.